So welcome everyone. Welcome to today's class. And today we are going to discuss the electronics DPP doubts, basics of electronics. And also today you will receive the next set of lectures for electronics, which is on transistor. Okay. So next we are going to get is a transistor and its DPP. So once we are done with the basic things like transistor ho gaya, diode ho gaya, then or basic digital electronics ho gaya, then I will push you towards the advanced questions. Okay, for which we started this revision session. Advanced questions like part C syllabus questions. Okay, and then you can say is a difficult problems of part B as well. तो जो भी बनता है, and also your DPP doubt. For example, you guys have sent some DPP doubts of OPM, which will be cleared tomorrow. Okay, and today we are going to do the difficult questions of basic electronics. These are also the difficult problems. Okay, the all of the problems were challenging, but not that. If you have a practice, you can do it. So let's see what was to be done. So this is our question number 1, and what they are asking is that what is the equivalent time constant for a RC circuit? So when you are studying the RC circuit, you know that you read the two equations that okay, current will increase and current will decrease, है ना? And this is an equation that you have, right? So this RC thing is known as a time constant. This is known as a time constant. So tau is equals to R into C. This is what we define as a time constant. For example, because you know inside an exponential, the things are dimensionless. Inside exponential, you don't have any dimension. But in the numerator, you have time. So in the denominator also, you should have time. So RC itself has a dimension of time. If you multiply R and C, the dimensions that you get is a time. And the parameter RC is known as a time constant. So basically it decides how fast your current will decay or how fast will be your charging process. So RC, which is equals to tau, basically decides the speed of charging and discharging. So these superchargers and all of these things are basically a very good circuits with a very good RC circuit, or you can say a very good time constant. Okay? So basically what they're asking is what is a RC? The problem in this question is that we do not have a simple RC circuit. We don't have this. If we have this, then we can say, okay, this time constant is RC. Simple, that is all. But in this, the resistance which our circuit has is a very complex thing. How to simplify that? That is the main idea. How can I simplify that? Okay. So in order to simplify the circuits, we studied the very first lecture, Thevenin theorem. So whenever you have to simplify the circuit, we use Thevenin, and in this also we will use Thevenin. So we need to do the Thevenin circuit around the capacitor. Basically, what is a resistor connected across the capacitor, right? This is what we want to know. Na? How much resistor is connected between the capacitor or with the capacitor. So I will choose these 2 points and I want to do a Thevenin circuit around the point AB. Basically, I want to know what is the resistance between A and B. What is the net resistance connected between A and B. Okay? So I need to do the combination of the resistors. I need to do combination of resistors. So what is the process of doing Thevenin circuit? A very simple is that first of all, open this up. So if you are finding between A and B, open the circuit between A and B. So you see, I have opened the circuit between A and B. And short circuit the battery, because when you know you have to find the Thevenin resistance, I taught you the process. You have to short the battery. Short the battery means convert your battery into the wire. So convert your battery into the wire. So I have converted my battery into the wire, which you can see here. And I have open circuited the points A and B. A and B may say whatever was there, I opened it. So that is no longer there. And now I need to know the resistance between point A and point B. What is the resistance between point A and point B? Now this circuit might be difficult to analyze. So that is why I am redrawing this circuit so that you get a better image. So I think all of you might agree that I can redraw this circuit like this. I have done nothing. I just picked this point and I have just put this point here. That is, so I pick this point and put it here. So I'm basically unfolding my circuit like this. So if I unfold my circuit, I get something like this. Okay, so nothing will change. I am not changing the circuit. It is just how I'm placing the circuit. That's all. So I'm just unfolding it. right? Similarly, I can even convert it like this. So I can, this is a vertical, so I'm showing it in a horizontal. Okay, this is a beautiful circuit. Now what I can do is use a Kirchhoff's law or a symmetry idea. So you know the symmetry idea I told you. Okay, if the battery is connected between A and B, or you can basically say that if you're finding the things between this A and B line, and if it is symmetric, but means whatever is above it and whatever is below it is same, then you can ignore the vertical lines, right? The things which are on the vertical axis. Or you can even use the Kirchhoff's law. Oh, sorry, Wheatstone bridge principle. What is that? R by R key ratio is same as R by R key ratio. So this can be ignored. R by R key ratio is same as R by R key ratio. So this can also be ignored. So I ignore the middle two resistors and I get this. Now these three are in series, these three are in series. So this is 3R, this is also 3R. And then they are in parallel with each other. So if they are parallel in each other, so the final resistance that you get is 3R by 2. So the final resistance that you get is 3R by 2, and you need the resistance between point A and B. So between point A and B, the final resistance is 3R by 2. And if you multiply by C, you will get time constant. So basically it is 1.5 RC. That is your final answer. Okay. So 1.5 RC is your final answer. So again, I just use the principles that you already know. How do you simplify the circuit? First of all, you choose the point around which you want to simplify. So I want to simplify between point AB. Okay, so I open circuit between AB. Okay, and I convert my battery into the wire. Okay, and then I just fold this circuit out so that I can look at my circuit clearly. So this will give me this diagram. And then I turn this circuit even more so that I can see even better. So then I use the Wheatstone bridge principle and I ignore the middle ones. Once I do that, upper 3R series 3R, lower 3R series 3R, and then they are parallel to each other. So 3R and 3R becomes parallel, becomes 3R by 2. So you know the equivalent resistance, you know the capacitance, multiply them together, you get a time function. Okay. So any doubt in this one? Do you learn something new? How to solve the problem, basically? Yes, you need to learn how to think all of this by yourself. That is the main idea. Okay. That is a skill that you want to acquire. Okay. So yes, so always remember the tools are same. I did not use any tool which was not taught in the class. I used that only, you can say, is the uh, Thevenin theorem. I used again the symmetry and logic. The logics remain same. Okay. Nothing new concept is going to come. Chali, next question. So now this is a three questions. So this is a comprehension question. So one circuit is given and then the three questions are asked on that. You might get some new knowledge in this question. You might. Okay, not that too, we're not going to separate, but little bit new knowledge will be there. So let's see. So I see a circuit in front of me. I see that there are two resistors. Okay, perfect. And I see there is one capacitor, there is one battery, and there are two switch. So these two switch are going to play a very important role. Okay, so let's see. Let's see, read the first question. So first question is that S1 and S2 are simultaneously closed. So basically I close this also, I close this also at time t equals to 0. Okay, so if I do that, I will get a circuit like this. If I close them, then they become a wire and the current starts flowing through them. So this is what I have. This is my circuit. Okay. Now the two things are given. What are the two things given? Number one, what is the power dissipated in the resistor R1? How much power is dissipated in this resistor? And what is the initial current through R2? And what is the initial current through R2? So these two things are given. And based on these two things, you have to tell me what is the value of R1 and what is the value of R2. So let's see what I can do. I see this circuit as a two different circuits. I do not see this circuit as a one circuit. I see it as a two circuits. One, this battery is connected to this, and this battery is also connected to this. Okay. So basically, what is happening here is that around this R1 there is 100 volt, and so basically this is my branch 1 and this is my branch 2. This is my branch 1 and this is my branch 2. I don't want to use fancy words, but these lines are known as branches. Okay. Both the branches are parallel and both the branches are parallel to the battery. It means both the branches are connected to the voltage of 100 volt. Okay. So I draw both the branches separate. So this is my branch number 1 and this is my branch number 2. Okay. So this is just the easy way to simplify the circuit. I can deal with them separately because branch 1 is connected with the battery of 100 volt. Branch 2 is also connected with the battery of 100 volt. The first circuit is a very simple circuit. It's just a battery connected to a resistance. Battery connected to resistance. So what is the power in a resistance? Power in a resistance has a formula, voltage into current, right? Or V square by R or I square R. I hope that you know this formula from the basic electronics, that the power dissipated around the resistor is Vi or V square by R or I square. So my circuit is very simple. My circuit is just a very straightforward circuit that, okay, voltage is 100 and resistance is R1. So the power will be V square by R. If you do the square of this, you get 10 to the power 4. And R1, R is R1. Resistance is R1. And the power is given to me. So power is 0.2. V square is 10 to the power 4. And this is my R1. Now I just need to cross multiply. And this will give me the answer of 50 kilo ohm. So R1 gives me 50 kilo. Now comes the second part. So this thing. This is an RC circuit. And you know RC circuit is getting charged here. So you're charging the RC circuit because when initially it was not charged, and when you turned, or you can say closed the switch, it starts charging, right? So this is an RC circuit, and you know in an RC circuit the current equation is this. The current keeps on reducing with time, right? I equals to I naught into e to the power minus t by RC. This is an equation. We saw that in the last class, or in the class of the capacitor circuits, right? What is the value of I naught? I naught is V naught by R, right? Voltage by R. You know this. This is also what you know. So what is V? So initial current is given to me. Initial current is 10 to the power minus 2 because it is given to me. You see 10 milliampere. 10 milliampere means 10 to the power minus 2. Okay? So current is 10 to the power minus 2. Voltage is 100 and R2 I do not know. So I will let it like this. So by cross multiplying, I will get R2 as 10 kilo. So I'm able to find the value of R1 and I'm able to find the value of R2. So I am able to know the value of both. So hence my option number B is the most best option here. Okay? It exactly matches with what I calculated. So that was my first part of the question. Any doubt in this question? Okay, so it's a 3-part question. So this is actually 3 different questions. All 3 requires the same amount of mathematics. So first question is solved and we get option B. Any doubt in question number 12? Please, is it clear or? Now this is little interesting, and question number 13, sorry, which basically says that, okay, when the capacitor gets fully charged, okay, so they say, okay, you closed this and now let the capacitor be fully charged. So once the capacitor is fully charged, okay, how much it can get fully charged by? If I say, okay, it is fully charged, then how much it is fully charged? Then Q equals to, so let's come to this circuit. Okay, na? What will be the maximum charge? Q naught. Q naught is nothing but CV naught. So C I don't know. I don't know the value of C, and I know the voltage is 100. So it can get a fully charged up to 100 C. Okay? 100 C. But I don't know C. I have no idea what is my capacitance. Okay? Still. So this is, okay, once the capacitor is fully charged, switch S2 is open. So we open this. It means this side of the circuit is gone. This is gone. And only the left hand side part of the circuit is remaining. So let me draw that. If I do draw that, I get this. I have R1, I have R2, and I have C. But now this C is acting like a battery. Okay? Because it is a charged capacitor. The capacitor is completely charged. So now it will act like a battery. For example, your phone battery. When you put the pin in your phone, the battery is getting charged. It is getting charged. But once you remove this plug, now that battery is acting like a battery. Basically, now it starts powering your mobile phone, right? So now what we are dealing with is a discharging of a capacitor. Now our capacitor will discharge, right? So our capacitor was now initially fully charged, and now you removed the battery. Now your capacitor will behave like a power source, and it will supply the power. It will give the current to these resistors. So the current will be there in this circuit because of this capacitor, and the charge of the capacitor will keep on decreasing with time, because now it is discharging, right? It is not charging, it is discharging. So if it is discharging, the charge of the capacitor will keep on decreasing with time. Hence the equation can be written as q equals to q naught e की power minus t by rc. This equation clearly shows you that your charge is discharging, your charge is decreasing with time. Okay? And if you differentiate this, if you differentiate charge, you get a current. So basically you can differentiate this, you will get q naught by rc e की power minus t by rc. Okay? Where q naught can be written as cv naught. So if I put my q naught as cv naught, and then you have rc, c and c cancel, so you get v naught by r into e की power minus t by r. So basically this is your current equation. This is how your current will be there in the circuit, and you can clearly see current will also decrease with time, because ultimately your capacitor will be gone. मतलब पूरा का पूरा discharge हो जाएगा, the capacitor will be completely discharged and the current will become zero. So in the discharging of the circuit, the charge on the capacitor is decreasing, the current in the circuit is also decreasing. So what we studied in the class was the charging of the capacitor. We were charging the capacitor. But once we completely charge the capacitor and then we are using it with the resistance, then what happens is that your capacitor behaves like a power source and the discharging happens. Okay? So this is my equation of a current. Okay, okay. Let's not carried away. And what is given to us? So they say that it is observed that after 5 seconds, 5 seconds के बाद, current is 0.74 milliampere. Okay, okay. So current is given to me as 0.74 milliampere after the time 5 seconds. So I put my value of current here. I put the value of voltage. How much is my voltage? So basically V naught. How much was my V naught? It was 100. What is my total resistance in the circuit? So you see total resistance in the circuit is R1 plus R2. So which is clearly you can see 50 kilo ohm plus 10 kilo ohm, which is 60 kilo ohm. 60 kilo ohm. And then simple e की power minus 5 by RC. Okay? That's all. Now let's simplify even more. So I can bring all of this here, and then I get 0.444 and e की power minus 5 by RC. Then I can even switch them basically, so that this thing becomes e की power 5 by RC, and reverse of this will become 2.225. Then I can just take the log on both sides. So I get 5 by RC equals to log of 2.225, and the value of this is given to me. You can see the value of this is given to me, which is 0.81. Okay, so this gives me 0.812, and then you can just bring C on one side and rest everything on other side. So if I do that, right, if I bring C on one side and rest everything on other side, you are left with this. And if you solve this out, you will get this, or you can say 102.6 microfarad, which is almost 100 microfarad, which is your option number A. Okay, so option number A is correct in this. Okay? It is milli, but I think it will be micro. I'm not sure milli or micro. What is the case here? 102. So it will be microfarad. 100 microfarad. Not milli, it will be micro. Okay. Yes. Any doubt in this one? Okay. So what has been done in this case is a discharging. It's a discharging of capacitor. The capacitor was fully charged, and now it is discharged. So the charge is decreasing with time. Okay. Charge is decreasing with time, and the current is also decreasing with time. At 5 seconds, the value of current is given. So I put my value of current and I put my value of time, and I already know the resistance. Resistance is R1 plus R2. So I get my final value of capacitance, which is 100 micro. So this is your question number 30. Is it clear, or anyone have any doubt? Please let me know. And then we do the question number. Okay, before we go for the question number 14, some things we need to ask. The one thing we need to ask is what is the maximum charge we can have? Okay? What was the maximum charge? Because we said na, ki it was charged. So we already saw that Q naught was CV naught. Okay, but we didn't know C before. But now we know C. So it is 10 microfarad. So with 100 microfarad. So it is 10 to the power minus 4. And voltage is 100. So it is 10 to the power minus 2, which means 10 millicoulomb. 10 millicoulomb. But in the C option, it is 2 millicoulomb. So that is why option number B, C, D are wrong. Okay? So it is just 10 millicoulomb, not 2. Okay? That is why this option is wrong. The next problem is very interesting. I mean, the most interesting problem, that is why we did all these questions, is the question number 40. This says that at the instant mentioned in the previous question, कौन सा instant था वो? What was the instant that was mentioned in the previous question? Time equals to 5 seconds. कौन सा 5 seconds? 5 seconds basically means कि, okay, you were only dealing with this circuit. Basically, you were dealing here. And for the 5 seconds, you let your capacitor discharge. 5 सेकंड तक आपने कैपेसिटर को डिस्चार्ज होने दिया. You let the capacitor discharge for 5 seconds. For example, you're using the mobile phone and you use the mobile phone for 5 seconds. So your battery is decreasing. Battery is decreasing. So let's find that how much battery will decrease. Initially, how much was the charge? Initially, the charge was 10 millicoulomb as we calculated. And you let your battery discharge. So after 5 seconds, how much your battery will be discharged? So you can use this equation. So Q equals to Q naught, which is 10 millicoulomb, and time is 5 seconds. And if you find the value of RC, you will get 6. You can check that. If you solve this out, you get 4.4 microcoulomb. 4.4 microcoulomb. It means you started your mobile phone with 10 microcoulomb. For 5 seconds, you use your mobile phone. You removed the plug and you are using your mobile phone. And after 5 seconds, your mobile phone is on 4.4 microcoulomb. Okay. Now, at this instant, what you are done? You are now in the question 3. So now let's see what is done. So S1 is opened. So after 5 seconds, what do you do is S1 is opened. So we open this up. So now we open this. Okay. So the current stops flowing here. So this is gone. This is gone. And S2 is closed. And this is closed. It basically means you again connected it with the battery. मतलब कि आपने फिर से चार्जिंग करना शुरू कर. So you let your discharging happen for 5 seconds, and after 5 seconds you again put the plug. So this is what we do na, we start from 100% and we use the mobile phone, and then when we see okay 44% is left, then we again stop using the mobile phone and put the battery, right, put the plug. So that is what I have done. When I put the plug, the charge on this was 4. It was not completely discharged. The charge on this was 4.4 millicoulomb, sorry. And R2 I know, and this I know. So let's make this circuit. Okay? So this is your circuit. So again, this is again charging. This is again a charging circuit. So in a charging circuit, you know the formula is Q equals to Q naught, 1 minus e to the power minus t by RC. Q naught you already know is 10 millicoulomb. So this is 10, this is 10. So you just multiply. And if you calculate RC, you will get the value 1 in this case. Because in this only one R is there. In the previous case, there are 2 R's connected. In this case, there is only 1 R connected. So it is 10 kilo ohm. So if you find the value of RC, it will come out to be 1. So this is your equation. But this is not a true equation. Why? This is a wrong equation. Although I'm charging the capacitor, but this is a wrong equation. The reason being because this time I don't start from 0. My capacitor started from 4.4. Right? In the first question, what I did was my capacitor was completely uncharged. So then I put the connection. But now when I'm putting the connection, my phone is not at 0. My phone is at 44%. Right? So I need to change my equation a little bit. So how will I change? I will change using the boundary condition. All I need to do is change my equation a little bit. And that I can do using the boundary condition. So what is the boundary condition? Boundary condition says at time t equals to 0, charge should be 4.4. So if I write this equation like this, you can check that your equation will be satisfied. If you put time 0, So 10 minus 5.6 will be 4.4. Hence my boundary condition is satisfied. So that is why your option number C is the best option in this case. Okay? If you are charging the capacitor from complete zero, then this equation is correct. But you are not charging the capacitor from full zero. You're charging the capacitor from the point of 44%. That is why you have a boundary condition ki at time t equals to 0, your charge is 4.4 micro. And that is all you wanted to check in all the options. Put the time in 0 everywhere. So question 1 is also good, but this does not match the option we have. Because according to the first option, the charge is decreasing. But no, you are charging. So your charge should increase. According to the second option, if you put time 0, you get 15.6, which is wrong. According to the C option, which is correct, if you put time 0, you get 4.4. And according to the last option, if you put time 0, you get again something 3.4. But here the negative sign is a problem. That is why I'm not choosing this option. Okay. Also, there is no logic of this 1.2. Okay. So that is why option number C is the correct one. Okay. So that is what we have. So in the first question, we charged from 0. Then in the second question, we discharged. In the third question, we did the charging from 44%. We started the charging from 44%, not from the 0. Hence, we have to change our equation little. So these were the three problems. Please shoot your doubts. Now let's go for the question number 9. I don't know how you have done this question, but I have a very simple idea of doing this question. And maybe I will be end up teaching you something here. So let's be very, very focused on this question. So this is in the circuit shown in the figure. So they have given us some circuit. And they are saying that find the steady state charge on C. Okay. So we have to see. And they have not mentioned which capacitor. And ultimately it will come out that both the capacitors will have the same charge. Okay. I will tell you why. But let's see. Let the answers come by itself. I will not give you any spoiler. So they are asking basically what is the steady state charge on the capacitors. Let's assume both the capacitors. They are asking for both the capacitors. Okay, steady state means that capacitors are fully charged. It means no current is flowing through them because current only flows when they are charging or when they are discharging. Once they are in steady state, then the no current flows. We covered this concept many times. Okay, so no current will flow here, no current will flow here. So the current will come from the battery. So let's say current I is coming from the battery. Current cannot go here. So all the current will go down. And then current cannot go here. So the current will turn back. So basically all you have is this side of the circuit. So this is 3 ohm. So this is your 10 volt. This is your 2 ohm. That's all. The thing. Current is only flowing in this side. Because current cannot go on this side. Because the reason being because steady state. Perfectly, it makes perfect sense. Okay, so now I can find out what is the current that is flowing. So the current that is flowing is the total voltage, which is 10, divided by the total resistance, which is 5, which is 2 ampere. So current flowing in the circuit is 2 ampere. Okay, so if the current is 2 ampere, what is the voltage around this 3 ohm? Voltage around this 3 ohm will be IR. So current is 2, R is 3, which means basically means 6 volt. So the voltage drop across this 3 is 6 volt. How much voltage will be dropped across this 3? 6 volt. Okay, ठीक है, इतना clear हो गया. Now I need what is the voltage across this capacitors? How much is the voltage dropped across this capacitors? Okay, let's take a journey with me. Let's take a journey with me. So we will start from here. So we have how much volt? 8 volt. We start moving. So first comes a capacitor. So some voltage will be dropped here. I don't know how much, but some voltage will be dropped. I don't know how much. Let's say V1 voltage will be dropped. Then you pass through this 3 ohm. How much voltage will be dropped here? 6 volt. 6 volt will be dropped across this 3 ohm. And then you pass through this. Again, some voltage will be dropped, but you don't know how much. So let's call it V2. And then you come back. Finally, when you come back, you have no voltage left. You are at 0. So this is 0, this is 8. You started with 8, you lose the voltage, or you dropped the voltage V1 on capacitor 1, then you dropped the 6 volt on resistor 3 ohm, and then you dropped V2 voltage on capacitor 2. So how much is the total voltage that I am dropping on the capacitors? The total voltage I am dropping on the capacitors is 2 volt, because out of 8 volt, 6 volt goes to 6 volt will be dropped to 3 ohm. The remaining 2 volt will be dropped either on a capacitor 1, some part on capacitor 1 and some part on capacitor 2. So total 2 volt will be divided between C1 and C2. So I will use voltage division rule. Okay? I will use voltage division rule, and let me be very clear about voltage division rule. Okay? If you are using the voltage division rule for resistors, or you are using the voltage division rule for capacitors, the rules are very different. Okay? Here the voltage division rule says V into R1 by R1 plus R2, and V2 is equals to V into R2 by R1 plus R2. Basically, if you are finding V1, you have to multiply by R1, and if you are finding V2, you have to multiply by R2. This is a rule I taught you. In case of capacitor, the rule is reversed. If you are finding V1, you have to multiply by C2, and if you are having C2, you can do it as a C1. Okay? So always keep this in mind. Why I need to do this? Because all of these things are basically class 11, 12, but you might have forgot this also. So this is what we have, a voltage division rule in capacitors. This is a voltage division rule in resistors. This I taught you already, and this is what I'm telling you now. So I have to divide 2 volt into 2 people. Okay? So how much will be V1? So your total voltage is how much? 2 volt. Then I will use C2. So C2 is how much? 6. And then C2 plus C1 is 3 plus 6, which is 9. This gives me 4 by 3. Then I find V2 voltage, and then total voltage is 2. Then C1 is 3, and then C1 plus C2 is 9. So this gives me 2 by 3. Okay, I found V1, I found V2. Then I found Q1 and Q2. So let's do Q1 and Q2. So if you do Q1 and Q2, Q1 is CV1, C1 V1. So how much is C1? 3. How much is V1? 4 by 3. 3 and 3 cancels, you get answer 4 microcoulomb. What about second case? C2 V2. So what is C2? C2 is 6. What is V2? V2 is 2 by 3. So again, you solve it out, you get 4. So the charge on both the capacitors is 4. Hence the answer is 4. Okay. So logic 1, current only flows in this side. Okay. What is the current in this side? 2 ampere. Okay. Then what is the voltage on this resistor? 6 volt. Okay. Then I start thinking about my circuit. Okay. If I start with 8, I lose 6 volt here. It means how much I'm losing on the capacitors. What is the voltage drop across the capacitors? 2 volt. 2 volt is a total voltage drop across both the capacitors. Then I need particular voltages. What is the voltage drop across 1? What is the voltage drop across 2? For that, I use voltage division rule. I get my voltage V1, I get my voltage V2, and then I find Q1 and Q2, because Q is CV, Q is CV. Okay? So that was your another doubt. Please, any doubt in this problem? But let me show you what is my idea. So this is the battery one. The battery one is 10 volt, and then I have this resistor 20 ohm. So there is no need to put any loops or as such, as you were saying, smaller loop or bigger loop. So no need for any loop. So this is just my simple circuit. Okay? What they are asking is what is the current through this resistor and what is the current through this resistor. Okay? So let's call it as R1 and let's call it as R2. They are asking the current around R1 and R2. Okay. One thing which is very clear is that this 10 volt is connected directly to 21, directly to R1. So this battery is directly connected to R1. So as you can see, the one end of this is here and the second end of this is here. So basically this 10 volt is directly connected to R1. So what is the voltage across R1? What is the voltage across R1? Simple, 10 volt. Voltage across R1 is 10 volt. Right. So what is the voltage? What is the current here? Current will be voltage by resistance. Voltage is how much? 10. How much is the resistance? 20. So you get answer 0.5. 0.5 ampere. Okay. Now let's think about this remaining part. Okay. You see these 2 points. If I think these 2 points here also, there no harm basically. What I want to do is eliminate this part and just focus on this side. This side is 20 ohm. This is this, and basically these 2 points A B. Okay. This is also A B, right? Because if this is B, this is B, and if this is A, then this is E. Basically, the direct battery you can connect. Okay, direct battery you can connect here, and then you can clearly see that this battery and this battery will fight with each other. This battery wants to give you current in this direction, and this battery wants to give you current in this direction. Both will cancel each other out. Hence, the current here will be 0. So I1 is 0.5, I2 is 0, which is why your option D is. Okay, you don't need to do any KCL KVL. You don't have to take any loops. That's it. Okay. So what I am doing saying is that this battery is directly connected here, giving you the current 0.5. This battery is also connected directly here. So let's just focus on this side. This and this will try to fight with each other, hence giving you no current, because both are the equal batteries. Okay, yeah, done. So this is your doubts of the basic electronics. Anything